All right, ladies and gentlemen, let's talk about a specific type of polygon, the good old triangle. So no longer are we just going to call them triangles. We're going to call them by two different names because triangles have a first name and a last name. Just like me, Mrs. Jones, I'm Tracy Jones. Okay, so I want you to think about these triangles all have two names, and the names come from two different things. One name comes from its classification of its sides, and one of them comes from the classification of its angles. All right, so we're going to examine some triangles and see the difference between them. So these are four different triangles right now. I'm going to slide this over for a second and show you my table here. Let me scroll it out a little bit. This matches this worksheet right here, this very top part. I'm just going to talk about it and write a little bit bigger so you can see it, and I can talk as I write a little bit. All right, so let's just look at these three triangles first and just look at the angles of the triangles. All right, that's all I want to look at. So this very first triangle, always angles have three angles, or triangles, I'm sorry. Because it has three sides, it has to have three angles. Right? So all the angles of a triangle will always equal 180 degrees, and we'll talk about that more in just a little bit. But if this angle, when I look at this little angle right here, it's called an interior angle because it's on the inside. That angle is an acute angle, like we talked about yesterday. It's not a right angle, a perfect corner. It's smaller than that, so it's acute. This is an acute angle, and this is an acute angle. All three of them are acute angles. So in that case, if I'm going to classify this by its angles, it's called an acute triangle because all three angles are acute. Okay? So if I slide down to this next one, when I look at this triangle, this angle right here is an acute angle. It's smaller than a right corner. This is an acute angle, smaller than a corner. But this one right here is like a perfect side of a corner. And if you ever want to test if an angle is a right angle or a corner angle, all you need to do is get a piece of paper. I'm going to use a yellow piece right here and slide it into that corner. And if it fits nice and perfectly and snug on those two lines, you know that that's a 90-degree angle. That's just a corner of a piece of paper check. So if this is a 90-degree angle, this triangle is called a right triangle. As soon as it has one right angle, it's called a right triangle. Now, do you think a triangle could have more than one right angle? Let's try. If I try to draw a triangle and there's one right angle, if I try to make this angle a right angle, I have to go straight up to make two right angles. Could it possibly be a two right angle triangle? There's no possibility because this is an open figure, and which makes it not a polygon. And to have three sides, 1, 2, 3, and two right angles, there's no possible way I can close that figure without curving this line over, which again would make it not a polygon because I can't have curved sides. Okay, so one right angle makes it a right triangle. Okay, let's slide on down to this guy. This angle right here is an acute, tiny little angle. It's about a 10-degree angle. This little angle right here is an acute angle, very, very small. But this angle right here is an obtuse angle. What makes it an obtuse angle is this. If I take that right corner check again, and I slide it into this corner and line it up with this line segment, you'll see it's wider than this right angle here. So that makes it an obtuse angle. Okay. So as soon as we have one obtuse angle, that's called an obtuse triangle. Okay. Is it possible to have more than one obtuse angle in a triangle? Well, let's try to draw one. There's an obtuse angle. If I try to make this angle obtuse, again, it's the same problem that I had with my right angle up here. I can't close it and make it a triangle if there's two obtuse angles. So a triangle can only have one right angle, and it also can only have one obtuse angle. The more obtuse it gets, the smaller these angles will get. If I made a very long obtuse angle, these little angles will be super, super acute because this angle has to be longer. Okay? So we have three different types of triangles: acute triangle, right triangle, and an obtuse triangle. So this is its first name. Its second name comes by its sides. And again, triangles have three sides, so we're going to name them by its sides. So you can see I just drew the same triangle on this column, but we're going to name it a little bit different now. So let's just look at the sides, the lengths of these sides. It appears that all three of these sides are the same. Remember how we used our hash marks earlier? So if they have the same number of hash marks, they're equal distance, equal lengths. So if it has 3 equal sides, it is called an equilateral triangle, because equal means equal, same, and lateral means sides. So it's an equal-sided triangle, equilateral. Now on this one, if this is a right angle here, I know this can't all be a 3 equal sides here because this wouldn't be able to be the same. But this side is the same as this side. And then this one across the way is a little bit longer. So it's not equilateral. All 3 sides are not the same. But 2 of them are. This is called an isosceles triangle. The way I remember that, if you look at the capital I, it has 1 long side and 2 short sides. So 2 sides are the same and 1 is different. So an isosceles triangle has 2 equal sides. Okay. Now it might look like this as a right triangle. It might also look like a party hat. I call it the party hat triangle because these 2 sides are the same length and the bottom is shorter. Or it might be like a rooftop isosceles triangle, like this, where this side is the same as this side length and the bottom side is longer. So all 3 of these are isosceles triangle. As long as 2 sides are equal, it's isosceles. Okay, and this bottom one down here, this is an obtuse triangle. We see that from this obtuse angle here. But this is a short side, this side's a little longer, and this third side is much longer. So I have 3 different sided angles. If that's the case, then it's called a scalene triangle. And the best way I remember that is that it's when things are different or they're scary to me. So different things can be scary. So a scary scalene triangle has 3 different sides. It's not all the same. It might look like that. You could have a right triangle like this that is different, short, a little bit longer, very long. Okay, so those are called scalene triangles. All right, so now that we see we have different triangles, you're going to put 2 names together. So instead of saying this is an acute triangle and this is an equilateral triangle, we can call this an acute equilateral triangle. It has a first name and a last name. We just put them together when we name them. Name them by their sides and name them by their angles. These here is a right isosceles triangle. There and there, because it's right angle and it's an isosceles. And these bottom triangles here are obtuse, scalene. First name, last name, first name, last name, first name, last name. All right, so let's take a look at this, how it breaks it down here, okay? Just a little bit smaller. All right, so classify each triangle by its sides, then its angles. That's why I've got 2 lines. We're going to classify by sides and we're going to classify by angles. So sides first. I can see this side is 8 centimeters and this side is 8 centimeters, so they're the same length. And this one's longer, so it's a different length. So a triangle with 2 equal sides, 2 equals our sides. It's an isosceles. And let's look at its angles. 26 degrees, 26 degrees, 128. Remember, a 90-degree angle is a right angle. Anything less than 90 is acute, and anything more than 90 is obtuse. So right here, this 120-degree, 8-degree angle makes this an isosceles and an obtuse angle because that angle is obtuse. This one has 3, 4, and 5 inches, so all 3 sides are different lengths. If that's the case, it's a scalene triangle. And this one little right angle makes it a right triangle. Here's a triangle that has 3 feet, 3 feet, 3 feet, all the same. So it must be equilateral. And all 3 angles are 60 degrees. All 3 of those are acute, so it's an equilateral acute. All right, this one I don't have the picture, but I have the angles. So I can look at this and classify it based on the angles. If it's got 2 equal angles, that means it's isosceles because if it has equal angles, it has equal sides. And then it has this 100-degree angle, which makes it obtuse. 14, 98, 68. 3 different angles, 3 different sides. So it's scalene, and again, it has a one above 90, so it's going to be a scalene obtuse. 38, 38, 104. Well, 2 angles are the same, so 2 sides are going to be the same. So it's isosceles. And again, 1 over 90 degrees, so it has to be obtuse. Okay, so now turn off the video and try this side over here, and then come back to see one more little video about the angles of a triangle, so I can prove to you that all triangles equal 180 degrees.